Let us provide an IUPAC name to a compound with the given structure, and the structure is here. Accordingly, we have to briefly find an overview of this structure. If you look at this structure, we find that this consists of a cyclohexane ring with a double bond having certain methyl groups as a substituent. Not only this, there is another long chain of carbon atom attached having a functional group to this cyclohexane ring. Now we have to select the root word, and the root word would be selected taking into consideration the preference of the number of carbon atoms and also the functional group attached here. We find that COOH group is attached to a chain of carbon atom containing 9 carbon atoms separately and attached to the cyclohexane ring. Therefore, this will be given as preference. And here, the long chain of carbon atom containing carboxylic acid group consists of a double bond at certain positions. Over and above, there are methyl groups attached to this carbon atom. Accordingly, we have to number this carbon atom present over here, and the numbering would be done in the order where functional group gets number 1. It will get a priority. So as we find, two parts are there in this case. And let us number the carbon atoms present in the structure. And if we start numbering, we shall number carboxylic acid group, the carbon of the carboxylic acid group as number 1, and then proceed to number different carbon atoms present over here. And accordingly, if you number, we find that there are 9 carbon atoms. And then we have to number the cyclohexane ring, the carbon atom of the cyclohexane ring separately. Of course, there would be 6 things only. And accordingly, if you have to name, now it is possible to name the structure. And the name of the structure will be, as we find, 3 and 7 position contain methyl group. So we shall, of course, the root word I have already made it clear that root will be the carbon atom containing 9 carbon atom, that will be root word. So that 9 carbon atom definitely represents nonane, but it is not directly nonane because there is a double bond attached at separate position and the substituents are also there. So we shall number as 3, 7, 2 methyl groups are there. We call it dimethyl. And with 9th carbon atom, there is a cyclohexane ring attached. So we shall write 3,7 dimethyl 9 and then represent the position of the cyclohexane ring. And since there is a double bond, we shall call it cyclohexene containing number of methyl groups at 2, 6, 6 position, second position, and 2 methyl groups in the 6th position. Therefore, it will be, I repeat again, it will be 3, 7 dimethyl 9, 2, 6, 6 trimethyl cyclohexene. Mark it is to be now written as cyclohexene. And nona, of course, represents nonane. And then, if not nonane only, there are certain number of double bonds in the longest chain. We have to mention those carbon atoms containing the double bond is starting from an end to the where the carbon of carboxylic acid is numbered as 1. Accordingly, we write further that this will be 2, 4, 6, 8. 2, 4, 6, and 8 marked with a different color here, and then therefore this makes tetra. And since a number of double bonds are there, it will be named as enoic acid. So the final name is of this structure is comes out to be 3,7-dimethyl 9266 trimethyl cyclohexane nona 2468 tetraenoic acid. Mark this E. That's there. Okay. This way we make out the IUPAC name of a structure given like this. And this is very good structure. Okay, thank you. Please do subscribe to our channel.